Assalamualaikum and good day everyone. Okay, today we continue with the second part for the first chapter. Okay, I believe that all of you already discovered what are the benefits, what are the limitation of IBS application, not necessarily in Malaysia but around the world. Okay, for those who still not yet read all the articles that I've gave you in the Google Classroom, please spend some of your times to do that as soon as possible, because if you didn't firstly understand or have an idea what are the benefits and what are the limitation of the IBS application and what are the definition of IBS, what are the other terminology used, maybe in future time you will have some difficulties or confusions if I use different terminology that represent a similar meaning. Okay, especially for the new mobility students, welcome to UTHM, and I hope you try to make your own time to do the self-learning. All the information that I already provided in the Google Classroom. If you have any inquiries, just personally text me or have some discussion in the Google Classrooms. Okay, after we discovered all the drivers and limitation of IBS, I'm sure that some of you realize that there is some contradiction between these two important things. Okay, let's see some example from our brainstorming session. Okay, here we go. If you look at one of the benefits of IBS, here is about cost saving. Okay, this is our collection of brainstorming. For those who missed this session last week, hopefully you get benefit from all the notes that I provided in Google Classroom. Okay, one of the important things that I want to discuss with you is about the cost saving. Okay, on the benefit or advantage of IBS is cost saving. But if you look at the challenges and limitation of IBS implementation, some of you found out that cost of using IBS exceed conventional method. So previously in the benefit section, it mentioned that when you use IBS, you have a cost saving. But maybe other researchers found that cost of using IBS exceed conventional method. You also find here, Daniel found that the challenges of IBS is it require high initial cost. Okay, it's related to cost. So we can see that there is contradiction. Benefits say that it cost saving, but at the same time, challenge shows that IBS cost it exceed or maybe higher than the conventional methods. So we will discuss this, why this happened. Regardless many of benefit and advantage of IBS still not really get practiced by the construction practitioner or construction players. Why this happen? Okay, the first reason is IBS is not implemented as holistic, only product replacement exercise. Okay, it's just instead of using the in situ concrete activities, it's replaced to the prefabricated element. It's not think or coordinate the other element of construction process. How about the delivery process? How about the design? How about the installation? How about the time management? Okay, management of the project itself need to consider several other things holistically. It's not just okay sebab you tak nak pakai kerja kotor you pakai IBS. It's more neat than the conventional one. It's not like that. Okay, you need to look into the more broader aspect. For example, if you want to do the IBS as effective and as efficient in the theory, you need to go through the process from initial stage of construction, initiation phase, until at the end of post-construction phase. Okay, so application of IBS must be initiated, or you have an idea to use this kind of method at the beginning of the project. It means kalau you memang nak pakai IBS, bukan macam okay, you kan kalau kita punya project life cycle start from the planning, okay, planning, design and construction activities, maintenance and so on. But katakanlah in the first phase of planning, you doesn't bother what kind of method you want to use. Then you design as it is lah. Okay, you design for the conventional methods, and suddenly you want to change when you want to start the construction phase. When you realize that kita dah kesentuh kat masa, you facing urgency katakan kan, jadi you need to shift into the other methods that you expect it more faster than the conventional one. So now suddenly decide to change the construction method after the design process completed. Then instead of using in situ concreting, okay, you tumpah prefabricated components, let's say, or using steel structure. By not revising the design of buildings or design of infrastructure that yang awal tadi you dah design, this cannot be like that. Okay, you need to go through, or you need to repeat again the process of design, because the design for conventional method and design for the IBS construction method is different. So you need to consider and have an idea to use IBS at the beginning of the project initiation, not change suddenly at the middle of project. Okay, that's why you need to think and coordinate all the construction phase to do the IBS application. Okay, you cannot compare apple you cannot compare apple to orange, so you need to compare apple to apple. If you want to compare two projects that using the different method, okay, katakan you have project A buat bangunan sekolah, one block of school building, and project B build shopping mall. School building using conventional method and the shopping mall using IBS method. Then you compare which project is more faster. Tak boleh lah, okay. If you want to do the comparison, it must be apple to apple. You must have the intention to use IBS at the beginning of the project. The IBS project should be faster and cheaper than the conventional one. Okay, so there's some other issues like workers issues, unskilled workers. That's why we equip all the students with the IBS knowledge. Okay, mungkin before this is very limited information. Masa saya sendiri dulu buat undergrad, tak ada belajar pasal IBS ni, tak ada idea. Okay, mungkin masa tu still IBS punya development is still new, but now you are very lucky to have the opportunity to get all this information in the syllabus. Okay, and other issues is coordination issues like M&E and the fittings. Okay, but at the end, if you intentionally plan to use the IBS method, it should be no problem to produce an efficient and effective IBS implementation for a construction project. As you know that there is several terminology and what we call as keywords that you can relate to the industrialized building system, from fabrication, mechanization, automation, robotics and reproduction. This is the process. I can say it's a process. It's a kind of degree of industrialization. When we talk about prefabrication, at the lowest point, for the prefabrication, okay, you can see here, prefabrication is a manufacturing process that generally takes place at a specialized facilities or factory, or maybe on sites where different materials are joined to form a component part of the final installation. So what you can see from the picture, the prefabricated elements were fabricated manually using manpower. It does not using machinery. Usually prefabrication is a small scale production, but it's depend on the machineries and equipment used. Okay, then we go to mechanization. Is when we say about mechanize. Okay, it's come whenever machinery used to ease the workload of the labor. Okay, so extensive usage of mechanical and electrical equipment and machineries in aiding prefabrication and construction activities. Okay, for the mechanization, it's what you can say is half the process is still run by the machine and half of the process assist by the labor. So machine is still controlled by the labor. So the process of mechanization is more complex than the simple prefabrication industrialization level. This is an example of prefabricated element that use the mechanization even though it's still controlled by a human. It's more complex is automation. We can see here all the process or procedures of production and manufacturing is systematically automated. Machines completely takes over the task performed by labor. Okay, kalau from the prefabrication tadi, it's manual labor force, and the second one is mechanization is half. Okay, half human power and half is from the machinery, and so automation it's fully machinery control. But the supervisors are still around, although industrial engineers and programmers become critical participants. But still, machine is not perfect. Okay, so automation process still need the supervisory from by the human. Okay, this is an example of mass customization. So this is an advantage for the automation process. Okay. Now is a lot of computer program that can help us to design and make our life more easier. Okay, so we can just selecting our preference, click, and come out with our custom made shoes. Okay, this is the example. Same like the construction component. Maybe you just need to put what are the dimension of the prefab component that you want to produce. Okay, how long, how depth it is, what are the material used, the maximum strength, the how many reinforced bar. Okay, it's a custom made. At more advanced, we go to robotics. Okay, all process using the machineries, automated using high technology machine with total control of machines. So usually it's using AI capability. Okay, AI is artificial intelligence. So you can see that the photo shows that the brickworks was done by a robot. Okay, and how accurate and how precise the robot can arrange the bricks compared to the human. Okay, this is more examples by using drone to construct buildings. How amazing our world today, even to do the plastering. Okay, and spraying all the concrete mixture. Here we have the construction robotics. There's a lot of examples that I will show you. I will share with you some of the YouTube clips in the Google Classroom, so you can enjoy and you can experience the multi type of construction industrialization. And the final stage of industrialization is reproduction. Okay, So this is more innovative, the latest technology by using a 3D printing technology. So this is the re-engineering of processes. We can produce the whole building by using one machine. It is the 3D printing technology. Even it's very mind-blowing how they can build a building in just for a day. It's amazing. Even you can choose a different type of materials, different type of design, thickness, the insulation. So the industrializations level that I mentioned before is actually the objective of IBS to achieve the industrializations. Maybe one day the construction industries become like the manufacturing industry. We just need to design by ourselves and order the pipe from the factory and install by ourselves. Who knows? Maybe now we can't because we think of it's very difficult to assemble. It's a large components need to transport from the factory to our place. But who knows, one day we have like a Lego system, so we can just plug and play. Okay, this is the example from Lafarge. Lafarge is one of the cement manufacturer in Malaysia. So what we can see here is they built two houses to compare the speed and cost. Okay, on the left side, okay, the building, the similar design buildings is using the conventional formwork timber, and the right one is fast built using the prefabricated or IBS application. Okay, at this phase, you can see that the fast built project is already nearly completed, but the conventional formwork kind of conventional construction method is still with a lot of scaffold here and there. Okay, so we can see the progress. So the results, the fast build project is save up to 36% in cost and complete 84% faster than the conventional. Okay, in terms of cost, the fast build only require 35,000 compared to 55,000 for the conventional systems. So this is kind of comparison that we need to do. We need to do the similar project using the different similar building using a different method. So we can compare apple to apple. Okay, fast build only require for this to complete. The conventional system need 25 days, almost a month. Okay, but a fast build complete in less than a week. Other than that, the fast build or the IBS system eliminate the plastering and bricklaying process. So this is other things that make the construction IBS method is more faster than the conventional. Okay, this is total workers required on site. Okay, for the fast build tadi, we only need about 360 man hours. For the conventional system, we need almost 5 times than the IBS application. So in summary, here you can see the fundamental of IBS. It's increase productivity, but at the same time reduce the workers. Even though we need less workers, but the productivity is increased. Okay, this is the what we call as a very significant benefit of IBS. Thus, IBS need to be redefined beyond product. So we need to understand that the IBS is not about the component itself only. No, okay, IBS is about the holistic construction process. Okay, how the process from the design, production of a component, okay, manufacturing process of the component, then the delivery component to the site, then the installation at site, and the completion and the post construction phase and so on. Okay, it's not only about when we talk about IBS, you cannot only simply define that IBS is a steel structure. No, you cannot think like that. It's the whole process of construction method. Okay, it involves industrialization effort, which is process, people and material. So as I mentioned before, and need to increase the level of industrialization to look at the larger perspective of prefab, mechanization, automation and production. So that's all for the introduction of IBS for the first topic. So before we end our lecture, I want to show you one articles about the key success factor in IBS project management. So this is among the factors that we need to consider to make sure that IBS can be implemented effective and efficiently. Okay. From this research, there are 16 key success factor. Okay, key success factor of IBS implementation. First is here, we can see here. First is about the effective communication channel across the supply chain need to be established in order to coordinate process and deal with critical scheduling. So the communication channels, the most important is between the contractor and the supplier. Okay, bila you nak hantar, bila you perlukan the components, okay, bila boleh siap the components. Okay, it's very important to have this good communication between the supplier and contractor. The second one is this key decision. Key decision on strategy, application, design, logistic details should be made as early as possible between all parties involved. It's good that everyone in a construction stakeholders involved in at the beginning of the project initiation. Okay, jadi masa project initiation tu kita dah libatkan supplier. Jadi kita tahu the capacity of the supplier to make sure that the production of our project can be delivered on time, macam tu kan. Okay, so the third one is extensive planning and scheduling. It's very important. It can relate with the effective communication. Okay, then management of supply chain and logistic activities. Okay, ada 16 di sini. So ada 16. I will give you this and several other papers. And your task for this week is to create one mind map. Title is the key success factor for IBS implementation. Until see you next week. Thank you. Assalamualaikum.